Hello and welcome back to my channel. Today I want to solve a question on latent heat of vaporization of water. Right now the question says a heater which is marked 100 watts will evaporate 0.025 kilogram of boiling water in 0.8 minutes. Find the specific latent heat of vaporization of water in joules per kilogram. So what we are looking for here is specific latent heat of fusion, right? So LV is question mark, we don't know it. Is that okay? Now we should also observe that the heat energy for latent heat of vaporization will be given as MLV. So the heat is going to be what? The specific latent heat of vaporization. Now what is given here? We have time, we also have mass, right? So our time is 0.8 minutes, but we don't use minutes in calculation, especially when we are using standard units here. So you see joules per kilogram is a standard unit, so we have to convert this minutes to seconds. So how do we do that? If you have 0.8 minutes, you multiply it by 60, it will give you seconds, right? So we're going to be having 48 seconds. We have 48 seconds. So what they mean is this entire activity takes place in 48 seconds that they are asking us to work out. So now we should also observe that the heat energy here is of a heater, and the heat energy for a heater can only be gotten by what? The current, right, times the voltage times the time it takes, right, which is equals to MLV. But in this case we don't have current and voltage, but if you observe here, we have what? 100 watt, which is power, and power is the same thing as current times what? Voltage. So we can use PT is equals to what? MLV, right? So if our P is 100 and our time is 48 seconds, the mass given is 0.025, and then we are looking for LV. You see, we have gotten it. All right, so our LV now will be equals to 100 times 48, all divided by what? 0.025. all right, so let's do our multiplication. 100 times 48 will give you 4,800 divided by 0.025. So our specific latent heat of vaporization of water will become 4800 divided by 0.025. So we have 192,000 joules per kilogram. Now don't be confused. This calculation has some hidden agenda. You see this 0.8 minutes, please don't go and use 0.8 minutes in your calculation. Convert to seconds, especially when mass is in kilogram and the specific latent heat of vaporization is in joules per kilogram. So the unit must match to standard unit, and the standard unit of time is what? Seconds. So this is it about this question. I hope to see you in the next video. Bye for now.